In our first video of the Laplace transform, we have seen the what is some basic definition and what is the Laplace transform, etc. In this video, we are going to elaborate this concept and go to more detail of the Laplace transform. So let's proceed for Laplace transform. Laplace transform. After the first part of the series, now we are going to go into the function of a class. Function of a class. We have seen the order of a function and or exponential order of a function. Now, what is the function of a class? A function ft is said to be function of class if its orders if it some exponential order as t into infinity. It's this one continuous function point interval of t. Now I have written the definition of a function of a class. What is the function of class of order of a class A if it's some exponential order as t tend to infinity and it is piecewise continuous function of a interval. Now this is our definition of a function of class. That means what is the say? Function of class is nothing but it is the if we say that what is the class? Class means group. When a function is said to be belong to some particular group, that is named by function of a class. That means if a function is belong to function of a class, some things like that, say A, B, anything capital letter you say or any letter, then for this you have to satisfy this condition as for some exponential order as t tend to infinity and the function have to be continuous piecewise continuous function for t greater than equal to 0. Now we have seen the function of a class. Now we are going to show the existence of a Laplace transform. When we say that if a Laplace transform of a given function exists, now we have now from this definition we can say that now when we say that the function of Laplace transform exists, now a function ft is Laplace, if a function ft Laplace transform, I am writing it here, Laplace transform LP, Laplace transform exists if when what is the condition of the sufficient condition for existence of a Laplace transform. If a function is Laplace transform will exist of a function if it function of a class of ft. We say that is the theorem said that a function Laplace transform, I am writing Laplace transform exists of function ft if it is function of class A if it's function of a class of A. Now that is the main theorem. Now we are going to prove this theorem and do into some more example of this topic. We have shown the definition. Now I have theorem of existence of a Laplace transform. Now we are going to express this in the mathematical terms so that we can easily solve the problem for our case. Now what is the existence of Laplace transform? Now what we can do? Definition. That means or we can write it. If ft is the function of a class, if ft is the function of a class of order is saying now, if ft is piecewise continuous of a continuous function and it satisfies the condition of order of exponential of a function. That means if it satisfies e minus sigma t ft less than f, then we say that what do we have I1, what is the I? We have I equal to 0 to, let's mark it 1, I equal to e to the power sigma e minus sigma t f of t. S, let write is, what is the value s? Okay, st f of t by definition of Laplace transform. Now that should be, now I am taking a mod, that should be less than equal to what? 0 to ti e st f of t dt. There should be less than, what is the value ft? What is the value ft is less than equal to what? M is sigma t, that is 0 to m t e st e sigma t dt. There should be, what will get? We will get e sigma minus s sigma 0 is the our condition. There should be m e et sigma minus s by sigma s. Now we have seen that since sigma is greater than s, okay, since sigma is greater than s, we find a finite value for the Laplace transform by Laplace transform. So which can easily clear that the Laplace transform of a function is exist. Laplace transform of a function is exist. Now write down it. We are going to the sum property of a Laplace transform. Sum property of Laplace transform or linearity property. Write down the linearity property. Now linearity property say, what is say that Laplace transform of c1 ft plus c2 f2 ft2 should equal to c1 Laplace transform of ft1 plus Laplace transform of ft2. That is our property. Now by there are some other property that have, now we have, what we have learned, this is the what we get. Now we will do the sum. We will derive the derivation of sum standard result. Now 1 when ft equal to t to the power n, what will be the value of Laplace transform? You can do it. So pause the video, do it now. So I am doing it. So do it individually. So how do you get Laplace transform of ft is nothing but 0 to infinity e sigma t, let st f of t dt. So 0 to infinity e minus st, what is the value? T and t dt. Okay, now from we can write it 0 to infinity e minus st. Now t and t n plus 1 minus 1 dt. Okay, I am writing it here for some reason. What do we get? Now we know from the gamma beta function 0 to infinity e x t to the power t n minus 1 is nothing but gamma n. Okay, by x m. Okay, now by using this property, what do we get? We get gamma n plus 1. What will be the value? N plus n s n. Okay, as n, that the value will be put. So what will be the value of gamma n plus 1? It is nothing but n factorial upon s n plus 1. For s greater than equal to 0, and obviously n plus 1 is greater than 0. Now remember this property. This is the our property. So this is our property there. Then we will do it next. When for where t is any real number greater than minus 1. This is our result. Now when we please do it now. What is the result? Now I am writing the result. Please derive the derivation is on you. For the here we get it. This is result for the non-negative real number. Okay, the real number greater than equal to minus 1. Now for integer we get what will the value? 0 to infinity est f of t n dt is nothing but n factorial upon Sn. This is n plus, this is n plus 1. Now what from this result we can find it? N plus 1 is gamma n plus 1 is nothing but n factorial, so that will be Sn plus 1. It will not change, so gamma 1 plus 1 will be changed, so that will be our result. Now next what we have do? Now we have find it the sum. So let how what is the this is the condition for the convergence of sum. Convergence means the if what is the convergence? A function has a sum finite value of limit of a function. if the limit of a function exists, then the what value we get is called the limit or convergent value, and the point at which is convergent is called convergent point. So there are some points that I have. Now that is this the sum result. Now I am going to the next topic. So let's do it. I am erasing it now. So we'll do it some question. Laplace transform of sine hyperbolic t. What is the Laplace transform of? Question. Find a Laplace transform of sine hyperbolic t. Okay, sine hyperbolic t. So we know solution. What we write in solution? 0 to infinity e to the power st f of t. What is the ft? Ft equal to sine hyperbolic t. Okay. Now dt we can write here 0 to infinity e to the power st sine hyperbolic t dt. Now we can do it integration by parts rather than we can do it exponentially. What do we get? Now in sine hyperbolic t, what do we know? Sine hyperbolic t is nothing but it is a t plus. Okay, let's add some constant. Yeah, let's add some constant. Yeah, okay, it is nothing but e minus at upon 2. Okay, so put the value here. So I am transform it ht by some constant angle multiplied by some constant. So that will be 0 to infinity a st. What will get? A at minus a sigma t by 2 into dt. So 2 will be outside. So 0 to infinity e. Let's a minus s. Okay, t dt minus 0 to infinity e s plus a t. When we integrate it, that will be result will be clear. 0 to a minus s. Okay, e a minus s t dt. Sorry, dt will not remain. No more. So that's will be result of. When we put that minus will change plus e minus s plus sigma t s plus a 0 to infinity. When we put the value sigma will here, that time will be infinity by 0. So there is nothing left. What is the value? When we put the value of t instead of sigma t in sigma instead of t, we get this time will be 0. There will be term 0. Now put the value of 0 equal to 1. We get minus. That when we put 0, that will be 0 to the power 0 something 0. So that's we will get minus will be outside a minus s. Okay, here I am taking common s plus a we get. Now that is our 1 by 2. What will get? S square minus a square. So s plus a minus a minus a. 1 minute. That will be plus. Okay, so a. So that's s cancel. So what is we get? That is our result. Minus a s square by s square. So what is the value of Laplace transform of it? Laplace transform of f sine hyperbolic at equal to a by s square s. Now you can do it. Cos hyperbolic t, tan hyperbolic t, at cos at. Okay, there are some other trigonometric function you can easily do it. So that's for today. Thank you.